Okay, yesterday we talked about varying degrees of pressure going to and from the equator in the northern hemisphere and the southern hemisphere. So remember, rising air is raises high up into the troposphere and gets blocked at the tropopause at the equator, okay? And then oscillating in a convection current, high pressure air drops at about 30 degrees latitude, okay, in the tropics. That creates a predictable region of high pressure. That high pressure is divergent, goes up to the subpolar low pressure belts and to the subpolar low pressure belt in the north, subpolar low pressure belt in the south, and then those winds converge, rise up into the sky, creating those regions of polar low pressure, and then of course the poles themselves are high pressure, okay? Now what we're going to go over today is that these regions in between these pressure belts have their own names, and they're called cells, okay? And they all have different places in which they are separated, okay? And of course we know that now as the pressure belts, okay? So at 0 degrees we have the equator. Going up 5 degrees north and 5 degrees south from the equator is what we call the equatorial low pressure zone. This is also called the intertropical convergence zone, and these are known colloquially as the doldrums because of their very, very low pressure, okay? They have no winds, okay? Going up from the doldrums, okay, in between the intertropical convergence zone and the subtropical high pressure belt in the north and the subtropical high pressure belt in the south, we have what we call the Hadley cells. This goes up to 30 degrees, okay, so that high pressure descending air, okay, falls at 30 degrees north and 30 degrees south at what we call the subtropical high pressure belt, and the area in between the equator and this belt is called the Hadley cell. So this is where you have your trade winds coming from the northeast going down towards the equator, and then you have your southeast trade winds going up towards the equator, okay, converging in the doldrums, okay? This is the Hadley cell, 30 degrees north and south. Then you have your Ferrel cells. The Ferrel cells is at in between 60 degrees north and 30 degrees north, and then 30 degrees north and 30 degrees south and 60 degrees south, okay? The Ferrel cell is where you have your westerlies, okay? So the westerlies in the northern hemisphere are coming from the west and they're going up this way, and then your westerlies in the southern hemisphere are starting from the west as well, and they're going down, okay, because they're going from subtropical high pressure to subpolar low pressure, and then subtropical high pressure to subpolar low pressure. The area in between is called the Ferrel cell, and then your polar cell happens, of course, at 90 degrees north and south pole, and then 90 degrees in the north pole, going all the way down to the subpolar low pressure belts, okay? So 90 degrees to 60 degrees, you have what we call the polar cell, okay? This is where you have your polar easterlies coming this way in the southern hemisphere, of course to the left because of the Coriolis effect, and to the right in the northern hemisphere because of the Coriolis effect, okay? These are your polar easterlies. So we have 90 degrees, 60 degrees, 30 degrees, and then the doldrums are in between 5 degrees north and 5 degrees south, okay? No wind, Hadley cell in between the equator and 30 degrees, Ferrel cell in between 30 and 60 degrees, and then your polar cell in between 60 and 90 degrees. And the same concept in the southern hemisphere. The only difference is that the winds change direction because of the Coriolis effect, going left always in the south and going right always in the north, okay? Thanks, guys.